Hi, so can I have your attention, please? So, did you guys just understand what exactly did I do just now? So this is basically hi, good morning, everyone in Indian Sign Language. And this is the exact problem about 63%, about 6.3% of the total population of India is facing currently today. And it's based on this, we got the motivation to exactly work on this problem statement and find out a solution. So the problem statement that we are working is titled Capturing Non-Manual Features of Indian Sign Language and Converting It into Text. And the ID is 1718. Our team lead is Pratisha, and to further explain our problem statement and how exactly we are solving the problem, I would like to call upon Pratisha.
So now to address the problem, I would like to say a few points about our problem statement. That is, over 300 different types of sign languages in the world are there, with most different from each other. Like every country has their own sign language. India has its own Indian Sign Language, America has American Sign Languages. All the sign languages varies from one country to another. So now coming back to India, India has more than 50 plus regional sign languages, that is, which is spread across different states of across the India. And the difference of the regional sign languages, it is due to the vast cultural diversity and historical origin. Like India, it's a very big country, so due to the cultural difference, we have different regional sign languages. So now coming to the current ISL translation systems, which mainly focuses on the manual signs, omitting crucial NFS such as facial expression, which provide essential context in the sign language communication. Currently, no platform or no technologies it offer live video translation for the Indian Sign Languages due to lack of databases for regional variations and non-manual features. So, especially the regional databases. So, due to less readily available of data sets for this regional sign languages, it makes it difficult to train the model and develop a solution. Now, on the base of these above problems, we have proposed our solution. So we have made a platform, or you can say an app called Bhavlipi, so which enables the users, particularly the individuals with speech disabilities, that is the deaf and dumb people, to translate Indian Sign Languages and its non-manual features into text format, like as live video format. So this includes detecting facial expressions, eyebrow movements, and other critical non-verbal cues through advanced image processing and machine learning. Addressing the diversity in Indian Sign Language, the platform will be designed with a database that supports different dialects and variations. So this, yes sir. So we have a technical approach.
Good morning. Good morning. I'm Rajit. Sorry. This is the tech stack used. For model training, we have used Python libraries such as OpenCV, TensorFlow, and MediaPipe by Google. And neural network, we have used LSTM and CNN. Here we have used LSTM and CNN for more accuracy. In the first prototype of our model, we are projecting 75 accuracy because we are using LSTM for video and CNN for more static data types. For example, when you have to say OK in Indian Sign Language, it goes like this. and we can process this by using CNN instead of LSTM, hence increasing the accuracy. For database, we have projected in .nppy format, and hence these are the Python libraries, and this is used in the TensorFlow framework, and Kotlin language is used for developing Android app, and Jetpack Compose for the interface. Hence, this is our model for the app. Here, the scanned observation from live video of the deaf and dumb people. It tracks the sign language, extract, hand, gesture, and non-manual features. By non-manual features, I mean the parts of the Indian Sign Language that do not involve the motion of hands. Because hand tracking is available in the market already, but eyebrow tracking, facial expression tracking, head nodding, hence are not that available. We put that data into our LSTM model, which we control with the help of TensorFlow kernels with our custom dataset, which converts the sign into visualized text output live from the video in our next slide. This is the feasibility and viability of our project. Due to the recent development in the neural networks in this age and era, it is more easier to make such machine learning projects because we don't have to use Python from scratch in building such projects. In terms of scalability, because we are for per sign language, we are using 30 videos, and each video is utilizing 30 frames per second. So hence the data accomplished to a large storage in only 200 sign languages. It accommodates approximately 2 terabytes of data, which we could not run locally on our device. Hence we may propose to use the solution as Amazon AWS or Google Cloud for seamless live interaction in the app. Potential challenges that we may face in this app may include the lack of comprehensive data sets online for ML models, specifically for Indian Sign Language and non-manual features. And non-manual facial recognition, for example, when we are raising our eyebrows, somebody may have their hair below the eyebrows, so the recognition may be hard, or due to the darkness, the edge detection of our eyebrow may be hard. So we are working on fixing that also. Real-time processing. In a day and era, there were many browsers available in our market, but Google came forward and gave the result within a second. So everybody have a massive switch to Google. So there is a user waiting time. Till that time the user waits. After that he tries to switch to another alternative. For example, ChatGPT. People put lots and hours into research from Google and Geeks for Bits and many sites, but they can simply type their problem and get their solution in ChatGPT, hence a massive boom. So we are aiming to do real-time processing in the low time possible so that the user stays on our app. For dataset creation, we are planning on collaborating with the Indian Sign Language Research and Training Center. We would be continue reading into the patents by the professors and workers of the current field. Development and testing. We develop a small, well-defined dataset focused on common signs on NFL. When our app would be deployed, we will track the regional variations in the app and also accommodate for the regional variations in the Indian Sign Language. Platform adoption. For the easier understanding of our app, within the app we will include some tutorials and some tutorials for Indian Sign Language and our app. So hence it will be easier for the user to adopt our app. So for the next slide, I would like to call Da.
Thank you, Rajat and Pratyusha, for explaining overall what our problem statement is and how we are tackling this solution. To focus on, I would like to impact knowledge on what exactly we are trying to solve for the target audience and what impact will it be creating for them. The first and foremost is the better communication. Now, the entire reason, the entire motivation of creating this solution is to bridge the gap between the disabilities people and the normal people to communicate effectively and conveniently. And that's what we are focusing, and that would be the potential impact at first. Secondly, would be the promotion of ISL. Now, since many of us are unaware of the basic differences, basic sign languages in our region, to promote that, to promote the learning of this modules, we have created learning modules along with videos, images, text in our app itself, which will promote normal individuals to also know and learn about Indian Sign Language overall. And next comes the motivation. Now, since these individuals will be able to better communicate with other normal people, they will not have this barrier to work and to explore new opportunities for themselves. This eventually creates employability issue, and this solves the employability issues for them, and also eventually help in the country's GDP, which is a part of the solution that we are trying to solve for. The social impact that it is creating is basically in our app, we are not just solving a sign language problem, we are solving it for the regional people in India. What we have found from our research is that the Bengal Sign Language and the people in, let's say, Meerut in Uttar Pradesh, they have a difference in the sign language. Even though it is overall the same, it comes under Indian Sign Language, but there is a variation. And to solve those variations, we are focusing on the regional dialects as well. This will eventually help us in having those individuals having a cross-border communication with each and other individual. Next up, we have to focus on not just to the people who have the access of the internet, all the modules that we have created within our platform that will be available offline for the people to learn and understand about ISL. This significantly improves and increases the possibility of the adoption of the platform, because now the people from tier 2 and tier 3 cities and villages will also be able to use the platform. Next up, we have the collaboration that we have planned for in the future. What we are thinking is the platform that we are creating is not just for normal individuals, but also to promote it higher, we will be collaborating with schools, colleges, hospitals, and even MNCs, so that whenever they're having a, let's say, a very common example, a Google Meet among them, then we will be collaborating with them in order to translate those sign languages in virtually, and thus promoting better communication among themselves. Next up, we have the research and the references that we have been used for the solution. So first and foremost, the official site of the Indian Sign Language, we have followed that extensively. Secondly is the machine learning models that we have focused on to creating our data sets that we are using through TensorFlow. And similarly, for body tracking, body posture tracking, and facial expressions, we have used multiple other resources, which eventually helps us in better and fine-tuning the model overall. So in order to better understand everything, we have a small video of our prototype. So we would like to go ahead with that, sir.
So this is the manual feature. Namaste. Manual. This is by. Now Indian. So these were the manual features. Now non-manual features.